Okay, this is the P4 paper from June 2024. It's question number 7, and this is an integration question. It's an integration question where we're going to be modelling differential equations. Okay, let's have a look at it and read it through. It says we've got the current x is defined by this equation, or modelled by this equation. Dx by dt is equal to k minus 3x. K is a constant. It tells me initially there is 0 current, so when I've done my integrating, that's going to be t equals 0, x equals 0 in this case. Part A, solve the differential equation. Yeah, I can do that, just integrate by separating the variables. And it says give our answer in the form x equals, so I might need to do a little bit of extra work there, but I certainly know how to get started. Dx by dt is equal to k minus 3x. So I'm going to separate out the variables, which means the t's go up there and the x's go down there. Excuse me. If I do that, I'm going to get 1 over k minus 3x dx is equal to, and then on the other side, just my dt there. Integrate, and then looking at this left-hand side, you shouldn't really have too many problems with this. I've got basically 1 over fx, so I'm going to have log k minus 3x, but then because of that minus 3 there, it's minus a third log k minus 3x. That really should not be causing you any problems at all at this stage of your revision. Integral of dt is just t plus my constant, and then we said, didn't we, that they told me at t equals 0, x was equal to 0, so that's going to be how I'm going to work out what my c is. So if I put that information in, I'm going to get minus a third log, and it's just k there, is equal to 0 plus c. Okay, so c is minus a third log k. So minus a third log k minus 3x is equal to, is equal to t minus a third log k. Okay, well, we need to get this into the stage of x equals. So if I need to get this into this x here, then I need to rearrange and make the subject of the formula. First thing I'm going to do is take the third log k over to the other side. So I'm going to end up with a third log k minus a third log k minus 3x is equal to t. So I could take a third out as a factor. Log k minus log k minus 3x is equal to t. And then obviously using my log rules, I can say that's a third log k divided by k minus 3x is equal to t. Remember, I'm trying to get x equals from this, so let's get the third over to the other side. Log k minus 3x is equal to 3 to the t. And all those previous stages were basically to get to this situation where I've got just a log function equals, because now I can e both sides. So I was aiming to get to this stage. So now if we do e both sides, we're going to get k over k minus 3x is equal to e to the 3t here. So if I've got that situation, multiply everything by k minus 3x, give me e to the 3t, k minus 3x. So I'm going to get k equals k e to the 3t minus 3x e to the 3t. And remember, still, I'm trying to get x equals from this. So I'm actually going to take that over to the other side. The 3x e to the 3t over that side is going to be equal to k e to the 3t minus k, like that. And then divide everything by 3e to the 3t. So x is going to be k e to the 3t. Now I'm just trying to think whether I want to have this as separate functions. K e to the 3t over 3x, over 3e to the 3t minus k over 3e to the 3t. And then tidying that properly, they didn't give me a format to make it look like, But obviously if I do the e to the 3t's, I'm going to get k over 3 here. They're going to cancel. And I'm going to get minus k over 3, and then it's e to the minus 3t here. So if I had that, we're done, but I'd actually take k over 3 out and have 1 minus e to the minus 3t here, just because that looks a bit neater. Let's just go back. Yeah, it didn't say anything about how they wanted me to set that out. So, okay, it's up to me as to how I do that, as long as I've got it as x equals. Right, given that the in the long term, the current in the circuit approaches 7 amps. They do this all the time. What do they mean by in the long term? That means that t is going to tend towards infinity. And if t is going to tend towards infinity, I can look at my function and make some deductions from there. So we're at part B here. Make it clear to the examiner. In the long term, t tends towards infinity. Use that language, it just make them more confident in what we're doing. And here, as t tends towards infinity, they're telling me that x tends towards 7. Okay, so if that's true, I can take my formula here and say, as t tends towards infinity, then I'm going to get 7 is equal to k over 3, 1 minus, in effect, e to the minus infinity. So just have a think about what e to the minus infinity, what e to the minus infinity looks like. Think about your graphs, okay? E to the x looks like that, which means that e to the minus x looks like that. So as we're going off towards infinity, what's happened to this function? It's tending towards 0, isn't it? Now, you don't need all that in there. I'm not even going to put that in as part of my answer. I'm quite happy to then say, if I've got to this stage, 7 is going to equal k over 3, 1 minus 0 in this case. Okay, so k is going to work out to be equal to 21. So k equals 21. That's my constant. If what they told me was true for part B, that as t tends towards infinity, x tends towards 7. And then the last part, what are they asking? So I know what k is now, obviously. Now find the time it takes in seconds for the current to reach 5 amps, and giving my answer to 2 significant figures. So that's okay, I can just go back to my part now here, part C. So we had that x is equal to, rather than it being k over 3, it's now 21 over 3. I'll put it as 21 over 3, I can see that's 7, but let's just put it as that to start off with. So that's what my formula really is, or in other words, 7 lots of 1 minus e to the minus 3t. And then they've said x is going to be equal to 5. So x equals 5. I'm going to try and work out what t is. So 5 is equal to 7, 1 minus e to the minus 3t. And this is a slightly simpler thing now to do to try and rearrange and get t. So 5 over 7 is 1 minus e to the minus 3t, which means that e to the minus 3t then is 2 over 7 by rearranging all that. Do the opposite of e now, which is to log both sides. So logging both sides, I'm going to get that minus 3t is log 2 over 7. So t will work out to be minus a third log 2 over 7. There's all sorts of things you could do with that, but they didn't ask for an exact value. They didn't ask even for it to have it in terms of log 7s or log 2s or whatever. They just said to 2 significant figures. So we can just work that out as a decimal. It works out to be 0.42. So quite a nice little last part. They could have made that a little bit more difficult for those 3 marks there. But yeah, that's that question. Hopefully that all makes sense to you all.